Awesome.
Yes.
So, okay, thank you. Well, today I'm going to be presenting the chapter 21 of the advanced art book that is about translating R code. And we have four main learning objectives. The first one is understanding what actually means translating R code, and also basically using some of the metaprogramming tools that we already learned in the metaprogramming sections in order to create domain-specific languages. I'm going to define that later. Also, the main focus of the presentation is going to be about creating these domain-specific languages for HTML and LaTeX. Uh, and I'm going to be focusing more on HTML because both are quite complex and LaTeX is more complex. So I'm going to be focusing on HTML, maybe comment a little bit about it and ask some questions, and then we can go to the LaTeX DSL. And this chapter, well, I already said that it was quite complex because it grasps or it encapsulates a lot of the tools that we have been learning across the book. Um, so it's a really good example or practical case where we are going to need understanding of environments, S3 objects, metaprogramming, and other related concepts. We're going to use Erlang library and Pur library for doing some functional programming. Um, I would like to start with a general question about what does translating R code mean. And here I had like a diagram for the past cohort, but it didn't render well. But it basically showed that uh, translating mean taking some R code and translating it to some another code or syntax in another language. And for that, we are going to use a lot of the metaprogramming tools and concepts like quasi-quotation, expression, and other concepts like environments. And related to that, I would like to do some statements. The first statement, it is that translating code is not the same as evaluating code. We already seen this in the metaprogramming section. We don't want to get the square root of 9, for example. We want to capture the code of the square root for using it then. Um, and the main thing here is that translation is going to preserve some structure, and the result is going to be some code, not a computed number. And that means that code translation relied a lot on metaprogramming. We're going to be using expr and an expr. We're going to be inspecting calls, symbols, and maybe um, remembering this AST concept that we saw across the metaprogramming sections. Also, I don't know if I said this already, but this is the last chapter of the expression of the metaprogramming section. So it makes sense that it's like a practical conclusion of how we can use these concepts. And yeah, actually, the practical goal of translation is domain-specific languages, and this means embedding a small language inside R. Um, And that means that R is going to become like an interface or like a front end for another language. We're going to use R code for creating another code. And actually, Hadley started the chapter giving the example of the dbplyder package. Um, and I've never used it, but by reading the chapter, it looks like it is a package for creating SQL code with R code. But in this presentation, I'm going to be focusing on two domain-specific languages. The first one is going to be HTML, and the second one is going to be LaTeX, or LaTeX. I don't know how to pronounce it in English. So before we start, like the practical part of the presentation, it's necessary to know some fundamentals about this translation exercise that we want to do. And the first one, let's start with the goal. The goal here is generating this code by doing this code. So the fun thing here is that we're going to create an HTML code, some R code that is going to then create the HTML code. And basically, we're going to do this by creating some ordinary R functions because they're quite complex, but basically this HTML code is generated via R functions. And for this exercise, we're going to, this first. This creation of the domain-specific language makes the translation easy, mainly because of 3 points. The first one is that this domain-specific language preserve the structure of the HTML code. That means that the nesting of the R function calls is going to be identical to the nesting of the tags in HTML. Second, we're going to follow a similar logic. That means that in the R function, we're going to have some unnamed arguments, and those are going to be the tag content. And also we're going to have some named arguments, and those are going to be the tag attributes in the HTML. And also we're going to be considering a really important thing in the translation, and that is that special characters needs to be automatically escaped. For example, the ampersand needs to be escaped with the code for escaping the ampersand, and that is this code. And yeah, for doing this exercise, we need to know a little bit of HTML, some basic tags. And remember, the goal is to generate this HTML code via R functions. So we're going to be treating in the example with these 5 tags. The body tag, that is the top level tag that contains all content, and also a heading tag, a paragraph tag, an boldness tag, and an image tag. That is going to be quite important because we're going to see that this image tag, it has a different structure than the other tags. And this is the second piece of knowledge that we need to know before doing the exercise, that the main structure of the tags is like tag, some content, and then another tag with a backslash or forward slash. And also we have another type of structure of the tags, that is the void tags, where we don't have like 2 tags. Instead, we have only one. And those tags, the important thing for the exercise is that they can't have like a content. They only have attributes. We're going to see that in more detail later. And the third important thing is tags can have some attributes. And for example, here we have a tag with the attribute ID. And here we have the image tag with the attribute source, and with the attribute width, and with the attribute height. And last, like the last piece of knowledge that we need for this exercise, is we need to know how to escape some characters. We already talked about the ampersand, but we will also be escaping the less than and the greater than symbols. So let's go with the practical side of this exercise, the real how to translate R to HTML. And here, we're going to be following a macro procedure to creating this domain-specific language. Remember that we want to accomplish this R code. And for accomplishing this R code, we will need to follow 4 steps. This is like my understanding of the chapter, like the stages that we need to be accomplishing to accomplish this goal. And the first one is creating an S3 object that translates and automatically escapes users' input. Then we're going to create a basic structure for tag functions. And then we're going to using that structure that we create for replicating it in a function factory. And last but not least, we're going to create an HTML environment of evaluation. So let's go with one of each of these steps. The first one is, well, the statement here is that we can translate R to HTML via S3 objects. And here, Hadley is constructing a class constructor and a method dispatch. So here the class is going to be advr HTML, and we create a class constructor named HTML. We also create a print method that is going to have this tag for showing in the output in the console that some code is already HTML code. And this second code block is probably the most important one. Here we're going to create the escape method with two behaviors. The first one is the character behavior. That is probably going to be the more important one because this is the behavior that allow us to escaping some special characters. So the thing here is if the users put some text in the escape function, it's going to be automatically escaped. And then when it is already escaped, it's going to be transferred in a class of advr HTML. And if the method is already an HTML, it's going to do basically nothing because there is nothing to escape there. And this architecture of the S3 method allow us to actually like transforming some text, like for example here, this is some text in a HTML text. And the most important thing about this is that if the user puts some special characters like greater than or less than, it's going to be escaping those characters. And maybe the most important thing of creating this via S3 is that double escaping is not going to be a problem. And also, if we try to escape some code or some input that is already an HTML class, it's not going to do anything. So that was our first stage in the path of creating a translation between R to HTML. The second stage is actually creating some tag functions. And here we're going to start by creating one example, and that is the p function that is going to create a p tag in HTML. And this p function needs to have two characteristics. The first one is that it needs to distinguish between content and attributes. And also, it needs to be able to manage the big amount of attributes that exist in HTML, considering that also the user can create some new ones. And when we already create this logic of this p function, we're going to be using that for creating the other function tags. So we want to create something like this. For example, here is the equivalent of a p tag. Here's the equivalent of a b tag and of a white I tag and so on. And maybe here we start with the trigger or more detailed part of the process. Here, Hadley creates a helper function that allows us two things. First one, he used dot 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 because we don't know in advance what arguments or what tags the user is going to be creating in the input. And also, these helpers allow us to separate the contents, that means like the actual content inside the tag, from the attributes that are the attributes of the tag. And if we see the structure of this list, we see that, in fact, we have a list of two elements. One elements are the named arguments. In these examples, the A argument and the B argument. And the other element of this list created via the dot partition helper is going to be the unnamed argument. That in this case is going to be 2 and it's going to be 4. So the important thing here is that we're going to use this helper inside a tag function for creating the actual tag in HTML. So remember, we are creating a p tag via p function. So in this case, we're going to be using this dot partition for creating the list of the arguments. And then we're going to be separating the attributes from the children. In my understanding, that is the content of the HTML. And well, Hadley here uses a HTML attributes function that he calls from like from GitHub. I haven't had the chance of looking into more detail, but I think the important thing here is that we are separating the attributes, we are separating the content and escaping that content. Here our escaping method comes into play. And then we're creating a class with our class constructor from this text that is constructing like the architecture of the tags using the attributes from the user and the children or the content from the user. And our p function works. For example, if we put some text, we're going to have first the indicator that is an HTML code and the actual tags that we want to use so encapsulating this content. And also it's going to work with the attributes. So here we have the content and the content is inside the corresponding tags and the attribute is inside the first tag, is inside the first tag. Okay, so that was the second step for constructing this translation between R and between HTML. Now let's go with the third step, and this is creating a lot of tag functions. And we can do that manually because it will be basically copy and pasting the structure that we already created for the pick function, but for the other tags. But maybe that is not so elegant or not so efficient. So here Hadley creates a function factory for creating tags. And the important thing here is, well, first he's using an rlang function that is called new function. And inside this new function is going to capture the intended tag. Remember that this is a function factory, so the input from the user is going to be a tag. Then he's going to capture the code that we already did for the for the p function. And then it's going to use this function color m that I don't remember exactly what it does. I just put the comment here, get the environment of the color frame. But maybe these two parts are the more important, basically capturing the intended tag and capturing the code that is going to be the function of that tag. And with that, we we are going to be able to creating function tags with our tag function factory. For example, here we're creating a tag function for the, sorry, no, yeah, a tag function in R for the HTML tag. And if we want to rerun our earlier example, we just need to create the P function, the B function, and the I function. And then we're going to be able to use it in some translation with these specific tags. So we already covered the main tag, but we also need to consider some void tags. And the void tag factory function is not going to be so different because the only difference is that void tags can't have content or children, and that in terms of R code, it means that they can't have unnamed arguments. So basically, in this function factory, we are putting an error message if the expression have some unnamed arguments. But apart from that, they are actually pretty much the same. And if we try this function factory for void tags with the image tags, we're actually going to create a function for creating the image tag in HTML. And okay, that was the third stage or step. Let's go with the last one, but equally important. Now our problem is that we need to store all of our tags, and actually HTML have a lot of tags. For example, here we have a vector with a lot of tags and a lot of void tags. And also we have another problem that is some tags will override with our functions, well-known R functions. And for example, here there is a Venn diagram from the past cohort. To the left, we have some HTML tags. To the right, we have some common R function. And in the intersection, we have some names that are tags and R function. That means that we had to comes to a solution that allow us to storage all of our tags without overriding the ones that are equal to the R functions. And the solution here is going to be creating a list, and then it's going to be creating an environment. So let's go with the first part of the solution, and that is going to be creating a list that actually make the translation work. And in this part of the code, we're actually creating the list. We're going to create a list named HTML tags, and we're going to map the vector tag with creating the functions for tags, and we're going to do the same for the void tags. And then we're going to have a pretty much functional way of translating our code to HTML. And okay, it's functional, it works, but it's not the more elegant way, because every time that we want to use some function for one specific tag, we have to tell R that that function comes from the list HTML tags. And that connects me with the second part of the solution, and that is creating an environment that makes the user experience better. And this environment is going to be basically the with HTML function that is going to be capturing the code or what the user wants to actually translate to HTML via enquo. And then it's going to be evaluating that code in the context of the list that we already create. And that list, remember, we have all of our functions. So it's like a data masking, but it's not data masking. It's like list masking. I don't know. But this is like creating an environment, and I say environment in air quote because it's not actually an environment. It's like using the list as is was like an environment. But with that environment, with HTML function, we can do what we already intended, and that is translation between R code and HTML code. So with this last part of the of the process of creating a domain-specific language, we have a useful way to translating the code. So I'm going to stop a little bit here. I don't know if somebody have like a question. This was like my best attempt to read the chapter and telling a story. Was quite difficult. I think we don't have any questions. Okay.
Similar logic applies for the sequel to the R sequel
Um,
talking about.
Hadley doesn't go into detail about that. He started chapter like giving the example of SQL, but he says like that SQL have a lot of dialects. I don't know what that means, but he said that, and for that reason, he's going to create some domain-specific languages for HTML and LaTeX. But probably it will be something similar, but actually I don't know in detail.
I understand. Thank you.
Thank you for the question. So, okay, let's go with the LaTeX part. I think we still have some time. Okay, so let's go with some fundamentals of translating R to LaTeX or LaTeX. And here our goal is that also translating R to LaTeX syntax. And this means that we can do this, like LaTeX syntax that looks like this, and actually mathematical equation or formula by doing this, some R functions. And like in the HTML DSL, we also need some knowledge about LaTeX structure. And the pieces of knowledge that we need for doing this exercise are these four. The first one is that simple mathematical equation are written like in R, like x plus y. The second one is that special characters start with a backslash. For example, pi. And more complicated functions looks like this. And for example, one common one is the fraction notation. That is this backslash, frac, and this A and B inside of this. I don't know how to say it, like these keys. Uh, and last, that mathematical function needs to be written like in this way, and it's going to be shown in this way. And okay, that are the pieces of knowledge that we need to in order to do the exercise. So let's go to R2 LaTeX creation of the domain-specific language. And here we're going to follow a macro-micro procedure. Remember that when we created the HTML domain-specific language, we went to micro to macro. Here we're going to start like with the big picture, and then we're going to start like working with the details. And in a more practical meaning or way, this means that we're going to start with some infrastructure. This means creating this function to math. and experiment until cover every use case. And we're going to do this in 4 stages. And these stage are basically distinguished with on 2 things. The first one is if we are treating with symbols or functions, and if these symbols or functions are known or are unknown. So the first stage is going to be converting known symbols, and the second stage is going to be dealing with unknown symbols, and this is going to be basically leaving other symbols unchanged, for example, X or Y. And also, the third stage is going to be converting some known function to their special forms. And the last stage is going to be wrapping some unknown functions to this form. So, what is different from this exercise, this LaTeX exercise, comparing to the HTML exercise?
Oh.
And I think the first 3 points are the most important. The first one is that the evaluation environment is not going to be a constant anymore. It's going to be dynamic depending on what the expression of the user is. And second, well, that environment is going to vary depending on input. And we're going to be handling noun symbols, but also we have to do a bit more of work because we are going to be also handling unknown symbols and functions. And before we go through these stages, first we have like the build of the infrastructure. And there is basically creating this toMath function that is going to capture this expression. Remember, this expression is the intended LaTeX expression. And then it's going to be evaluating this expression in this environment, LaTeX M. And then it's going to be using or telling, well, R is going to tell this output that is going to be actually LaTeX code. And for this, we replicate the strategy of using S3 programming. And maybe the most important thing here is that LaTeX, this function LaTeX M, well, first it's going to be created later, but because it depends on the expression that the user is going to input. And okay, let's go step by step or stage by stage. Remember, our first stage is how we deal or how we translate some noun symbols. And probably this is the most easy one of the 4 stages because it's basically declaring a vector of all of the Greek letters and then creating an environment where first a list and then an environment with all of these Greek letters. And then we're going to use this Greek environment and we're going to insert it in the LaTeX environment. And remember that this LaTeX environment is built in the infrastructure. And this is what I mean when I say that this evaluation of the expression of the user is going to be dynamic. Well, here until now we have only one possible scenario that is noun symbols, but we're going to be adding more environments to this LaTeX environment. And if we try this, we're actually be able to see that if we put pi, it's going to be like adding the backward slash, or if we put beta, we're going to be, or the toMat function is going to be adding the backward slash. Okay, let's go to the second stage, that is translating unknown symbols. And maybe this is more complex, and here Hadley creates some helpers. Actually, he's basing his helpers on other helpers from the section 18.5. So I actually haven't had the chance to look at this code in detail, but I understand that what we are doing here is walking the AST tree of the expression that the user is putting, and capturing the symbols that the user is using in his expression or in her expression. So, for example, here in this expression, we use X, we use Y, A, B, C, and this helper is going to walk through the tree of the code tree, and it's going to give us this output that these are the symbols that the users actually is using. And we are doing this because, like, comparing this scenario with the known symbols, here we don't know in advance what symbol the user is going to use in his expression. So we have to do it like dynamically. And then we can build the environment based on we can add this new environment, this symbol environment, to the LaTeX environment. And okay, that is one part, but the second part and more important part is this, that we're going to add this new environment, this symbol environment, and also we're going to add the Greek environment that we created before. And with that, we're going to be able to translate the LaTeX expression and LaTeX expression with known symbols and with unknown symbols. And maybe something important here is that we are declaring that the Greek environment is going to be a child of the symbol environment, and this gives preference to Greek over default. And this is because we want that some specific characters or symbols, for example, pi, is going to be actually uh, classified as a Greek letter and not like an unknown symbol. And if we experiment with our interface with our function toMat, we're actually going to see that we can our function preserve the unknown symbol and transform the known symbols. So, okay, we have seen two stages, known symbols and unknown symbols. Let's go with a function. And here, for dealing with known function, Hadley is creating like two simple helpers. One for like doing the string manipulation of unary operators, and other helper for doing the transformation of strings to create the binary operator. And with these two helpers, we're going to, Hadley is going to create like an environment that has the most common example or of operator that we are going to be using in LaTeX. For example, the plus one, the subtract one, and a lot of others. And then we're going to add this environment of known functions to the environment that already has the Greek environment and the simple environment. So our, our translating exercise from R to LaTeX is going to work with symbols and with known functions. So we are almost done. We need to go through the last stage. Maybe it's the more trickier one, but the strategy is kind of the same. We are going to also be using this helper that relies on some helpers for capturing the the expressions, the functions and the operator that the user is using in his expression. And also we are going to be creating a function factory for unknown operators in order to insert this in the LaTeX environment and be able to treat with these unknown operators. So in this last stage, we have two important helpers. The first one is this one that walk through the AST and extract the functions and operators that the user is using. And the second one, this function factory that create functions for unknown functions. But the important thing here is we are going to use these two helpers and we're going to insert them in the LaTeX environment. So with this, we're going to be able to deal with all of the possible use cases. That means we're going to be able to translate symbols and to translate function. And if we try this, our final environment and default translation work. That means we have a tiny function that is TOMAT that actually can translate some R code to LaTeX syntax. And okay, that was rough. Let's do a synthesis of everything that I said. Well, the main focus of the presentation was creating two domain-specific languages. First, we create an HTML domain-specific languages via a micro-macro procedure, and that we did that by creating an S3 for translation. Then we create a tag function structure. Then we replicate that tag function structure in a function factory. And then we create an execution environment that we call with HTML. And for LaTeX was a bit more complicated because we had to deal with the fact of dynamic environments and unknown symbols and functions. So for that, we adapt a macro-micro procedure where we build an interface that contains a dynamic environment. And we had 4 stages for dealing or creating environments for dealing with known symbols, known functions, and unknown functions. And then we integrate all of those environments in the dynamic environment that is contained in the TOMAT interface. And some final remarks. Well, this chapter actually integrates a lot of core advanced art concepts that we find in the book. well, we use a lot of metaprogramming tools. We use some object-oriented programming tools. Uh, we have to deal with environments and with scoping and dynamic function generation. And maybe the takeaway here, or at least for me, is that R enable us to create languages inside the language, mainly because of the metaprogramming like tools that R has, um, and maybe that allow us to think that translation comes naturally from how R is designed, and that creating some domain-specific languages is like normal. It's not like a hack or a trick. And I will I will say that advanced R show us how to build them in a clear, safe, and maintainable way, at least for learning purposes. And yeah, I think that's it. Happy to be presenting this in the time. Was quite challenging, but happy to discuss this this chapter.
That was great. I did not think it would fit, even with you guys possibly delaying while I
I don't
was.
know, John, if you're talking, I
Oh,
can't
you
hear.
can't
I don't
hear?
know if I'm the
Okay.
problem.
No, it's probably me. Um,
Microphone.
yeah, it's using it. What it's not using the right microphone, so you might be able to hear. Uh, anyway, just that was great. Thank you for making it through it without, while I was spacing out. Sorry, I was late.
Oh, sorry, I can't hear. I'm going to try to. Oh, okay. Um, yeah, I don't know if somebody have like a comment, a thought uh, about this translating R code, or maybe somebody have done this in the past.
Just wondering what could be the use case for this kind of things to be done. I mean, why do we need to do all this kind of translation?
Sorry, I think I was the problem. I
I
was.
just wanted to see if somebody has done it. What is actual need for this kind of things to be done?
Well, like the HTML stuff underpins a lot of uh like which is it like BS lib, or there's like, yeah, like anything that's using R code to generate anything that goes on the web, um presumably uses some kind of version of this.
Maybe that's
HTML tools is the package that I was thinking of, not BS8.
so. This is how the Corto has been built. I mean, Corto or R Markdown or anything. Just
Not Porto, but um, like knitter would be this sort of thing. If you've worked with any databases in R, it's using this sort of thing under the hood.
okay,
Uh,
okay, okay.
I haven't done this, but it has some definitely intriguing ideas in it. Um, so yeah, I was able to fix my mic at least. But yeah, there are lots of packages that do this, and I told Martin when I reviewed this that I don't think I've really absorbed this chapter yet. I feel like there are cases where I could have used this, and now I'm going to be on the lookout for thinking this way.
Hmm. Okay. Yeah, very, very nice idea though. I never thought those, but just trying to see where it can be used.
Anytime you are trying to work with something that already has it's not programming language per se, and it's not, human language. It's you're trying to work with something that has a set of rules. And so this way of looking at it lets you translate that set of rules into our functions. But I don't have a good example because just today I was like, I'll bet I have cases where this would be helpful that I haven't done it. haven't thought of it this way. So
Got it. Thank
yeah.
you.
Hey John, and they used to use this package with all the Git like function is not something like this, or
Yeah, Gert, which is the underlying package for Git, is kind of this sort of thing. And GH, the Git API, is kind of this sort of thing. It's a couple levels abstracted because it's really hitter two is what is the translator for GH. But still, it's the idea of it at least, and I'll be watching for more for sure.
I think that I don't know. My main takeaway here is that we can be like we don't need to be bouncing between language too much if these tools exist. Like if we want to use like a bit of HTML or a bit of SQL, maybe I can do it by R instead of learning the language.
To a degree, like someone has to have done this because if you don't know the language, this sort of thing is really hard.
Yeah.
But writing this thing, writing wrappers and translators, can be really powerful for sure. Like I've definitely used a bunch. XML2 is built into. If you've used RVest to scrape web pages, that is kind of a wrapper around a bunch of different DSLs. And again, like DB plier, DT plier is an interesting one because that is translating data table to dplyr, and so it's like two different R packages that have their own kind of language within them, and so it's translating between those. Yeah. All right.
So,
So yep, go ahead.
Yeah. See, do different languages, meaning that, say, for example, we have Python, which needs to be compiled at source level, and R, which also needs to be.
Python's also a scripting language like R.
My bad. I was looking at SAS. SAS, if at all, like
Okay.
you want to do something, it has to be compiled. I mean, like can we do something like that? I mean, like two different languages?
That isn't like directly related to this.
Okay.
But we're going to be seeing in the coming weeks, in a couple of weeks, C++, Rust, and C are compiled languages, and you can see how you can embed those into R for some really cool stuff. All right, and so next week we have Ella with debugging, and it looks like you're aware of that, so that's good. All right. And we have people signed up for the rest of the weeks. We can't miss any, or we run into the time change where things get crazy. So hopefully this will be all set. And hopefully I won't get busy with work and totally lose track of time next week. But if I do, it looks like you guys started without me, which is great. So please do that again if it happens. And I will see you all next week.
See you next week. I will definitely be here.
All right. Bye.
Bye.